should be symmetrical. Okay, so I'm just trying to start to visualize this. And so then he would start to graph it. So when x is 0, y is negative 15, clear down here. When x is 1, y is negative 16. When x is negative 1, y is negative 16. Why are we getting a downward facing? Exclude 0, take away 0, take away 15. Okay. And so he would just continue to do that. And then graph his points. So I would just show a table of values like that the best you can.
Okay.
Let's see what happens when x is 2. When x is 2, something's not right here. Is this equation right? Did I write it down correctly?
Yeah. Yeah.
I did?
Yeah.
X squared.
Minus 2x minus 15 equals 0.
Take away 2. Take away.
Yep.
But we can't go back to. Oh, this. This looks like a curve. Okay, well, go ahead and see if you can get your table values in. I'm going to put this in the calculator, make sure we got it right.
Okay. Guys, I hate math. I hate math. I'm muted, but I hate math.
1 squared plus 2. 15.
Do you think she realizes that I've been wearing the same exact thing for the whole week? Probably. She probably like, you're disgusting. I'm like, is it?
So this
Do you
guy's
know there's
got to
something
be.
called a washer?
We should have a graph that faces this way. That's why I'm confused. Okay, so 0 take away 15 equals what? 1 take away 2. Negative 1. 18 is negative 16. 1 take 1 plus 2 is positive 1. Take away 15 is negative 14. So this should be negative 14. Why is it not symmetrical? Oh, well, I guess it's just not 14. Okay, I think that is working. So you could continue your table of values. It's just that the vertex is not on the axis. That's the problem. That's why my graph doesn't look right. It's more like.
Oh, yeah.
So negative 2. Negative 2 squared is 4. plus 4, 15 plus y. So that would also be negative 15. That would be negative 7. So on your document, you're going to say something like, Carlos creates a table of values, and then you'll write it the best you can. You might have to do it. I don't know which way it's going to work better for you, up and down.
Okay.
Suppose you could do an X and a Y underlined,
Mm-hmm.
and then go down. I don't know.
Okay.
And then Carlos will graph his points.
Okay.
To find them.
Okay.
I'm actually going to pull it up on my side too.
Okay. Guys, she's sick and tired of me. She is so done with me because I'm so stupid. She's like, but do you mean you don't know what 5 times 6 is? Like, I'm sorry, I never learned my times
Okay,
tables.
so who's next?
Zach.
Okay, Zach, I like to graph the related quadratic function and use my graph to find the solutions. Okay, so that one's pretty easy. You're going to put that in decimals. You're going to, and then like take a screenshot. And your solutions are where y is 0. So you're looking for your x's. Remember we did that before?
Yeah. Yeah. Okay, do you want me to share?
Yeah, let's see what it looks like.
Okay. Just like that.
It hasn't come up for me yet.
Oh. Let me try again.
Okay. Can you zoom out just a little bit so we can see what it looks like all together?
Oh. Like all the way out?
Okay. So when you graph it,
Mm-hmm.
oh, you know what? I know that you need a y equals y instead of equals 0.
Oh.
It didn't look quite right.
Yeah.
There we go. That looks better.
Yeah.
Okay, so now we can see the vertex. And so when you graph it, when Zach graphs it, he looks at where y is 0,
Mm-hmm.
and he gets his 2 solutions right there. Do you see? Like
these 2?
Mm-hmm. Yep. So those are his 2 solutions.
Uh-huh.
So like, I don't know if that's -3.
-3
and 5.
and 5. So is that all I have to do, basically?
So I would put the screenshot of at least that part of the graph. So you're seeing like your x-axis and your vertex. You don't need the whole thing. Yeah, that works.
This works? Yeah?
Mm-hmm.
Okay.
Yeah. And then paste that and say, so Zach looks for where y equals 0, and he has his solution.
Okay. Okay, wait, I'm just gonna write it first.
Okay.
When y equals 0.
Uh-huh. And that gives him two solutions for x, right?
Mm-hmm. Okay. Now, okay, hold on. Just like,
It'll probably make your table look crazy. You probably have to make it, smaller, but it'll.
Yeah. Okay.
Like on itself, it probably wanted to bounce to the next page. Maybe. I don't know, maybe it worked fine. Maybe it auto.
Yeah, I think
So when you scroll down, it may have taken to its own page. You might have to make the image smaller.
Okay.
Oh, that's not your copy.
It's not. Yeah, I have to redo it.
So you should have a copy right there, right? I mean, you wrote on it before.
It was right there. Now it's not. So.
I feel like that's the original, not your copy that you started.
Yeah, that it was the original.
I feel like your third tab, right?
This?
Yeah, is that it?
No.
Is that where you wrote? Oh, I see.
No, it was this. Yeah.
I wonder if it would be easier to just do it on that other document and just say Carlos's strategy, Zach's strategy, not try to use the table.
On this, on here.
Do you think that would work?
Maybe. I could try.
And then he had the table of values.
Yeah.
Let's get Zach's on the way you had it, and then we can, on Google Doc, you should be able to put in a table.
Oh, I can.
You should be able to.
Okay.
Like insert. Go to your insert tab in the table, up a little. Yeah. And you want it to be, you can decide if you're going across or going down, but you just need 2 rows, right? Yeah, that will work.
Yeah. Okay.
Okay. And then you can put like X and Y. So I feel like actually after looking at it, Carlos said that he was going to examine his table. So I don't think that he's going to graph the points.
Mm-hmm.
So points back in. So like 0, -1, +1 and -1.
Okay.
not sure that I remember. Oh. Still. There. So there's the values. He actually needs to graph what x is going to be when y is 0. I don't understand how this gets a form without graphing. But
Yeah.
x is 0.
So should I just fill in the table or not?
Yeah, I would.
Okay.
I think that's what. He may be going down a little bit farther. Maybe he's going to keep going until he finds where y is 0, perhaps. That might be what he means.
Okay.
Let's see what happens here. Because we know one of the solutions is -3, right? So if I put in 3, I'm getting 3 squared. Take away 2 times 3 times 3. Take away 15. 9, 6, 3. There we go. So he can see that there's one solution. So I think you just need to make a longer table.
Okay.
And then your words are going to be, so Carlos examines the table and finds out what x is when y equals 0. Right? This is a trial and error way of doing it. Kind of a hard way to do it. Let's see. So 4 squared is 16. Take away 8, take away 15 equals 15 is -7. And that would be 16 plus 8. 24 taken 15 equals what? 9? One more should do it.
Oh.
So 5 squared is 25. Take away 10, take away 15 equals 0. So there. He found, by examining his table, he found 2 places where y equals 0.
Okay.
Okay. When we looked at the graph, that's what we were looking for, right? Where y equals 0. And we got -3 and +5.
Oh, so how many? I only have 3 down. Am I supposed to do all 11?
Yeah, I think that you'll have to go make it bigger. Because it takes that many before he actually finds his zeros, right?
Yeah, okay.
Let me erase some of this, my scribbling. There.
Is the 3 by the -2, is that in +3?
That's a +3.
Okay. Okay. Okay, there.
And then just explain that Carlos is looking for where y equals 0.
Okay.
He knows those are his solutions.
Okay. And then Zach
Clarita.
was looking for
Oh, Zach.
Michael's.
Oh, okay. So Zach, that now you can put your image there, that you graphed, right?
Yeah.
Okay. Yeah, and Zach's just looking for looks at the graph to see where the parabola crosses the x-axis, right? And those are his two solutions.
Crosses the y.
The x-axis.
The x, yeah.
Okay. When y is 0, you're on the x-axis.
Yeah. Okay.
Okay. Now this is Clarita, right?
Mhm.
She wants factored form.
Yeah.
So for factored form, we're going to set the y equal to 0. Okay, and then do you remember how we do FOIL, right? When we multiply our, whatever we have,
Mhm.
right? Okay, we're doing the reverse of that. Okay, we're going to factor. So your instructions are going to be, so Clarita likes to factor the quadratic equation into two binomials. Okay, so this is like going backwards from FOIL. It's like, what would we have to multiply by? Okay, and remember how we do that? We are looking for a number that will multiply. We're looking for factors of negative 15 that will add to the middle number. Okay, this is how we factor. So, and I would just say that. Clarita is going to factor the quadratic equation. She needs to find a pair of numbers that add to negative 2 and multiply to negative 15. And then we'll see if we can figure that out, what it would be.
Okay.
So now I'm thinking to myself, what times what, doesn't have to be times itself, is going to equal negative 15. What can we multiply together? Think of your times tables, or think, let's see, will 15 divide by 2?
Will 15 divide by 2?
Yeah, will it? 2 times something equal 15?
No.
No. Will it divide by 3?
Yeah.
Okay. So 3 could be 1. And then what would be the other factor? What is 15 divided by 3?
45.
Divided by.
Oh. 5.
Okay, so 3 and 5 work to multiply. One of them has to be negative. Can we come up with a negative 2 by adding them? Well, which one would have to be negative to add up to negative 2?
15.
Which of these two? If I want could I
5.
do 3? The 5 would need to be negative, right?
Yeah.
Okay, so negative 5 plus 3 equals -2, and -5 times 3 equals -15. So we found the numbers.
Mm-hmm.
Okay, these are going to be the two factors. It's going to be x minus 5 times x plus 3. And if you go through FOIL, you'll see that this comes back here. So this is the factored form. If I go through FOIL, I've got x squared plus 3x minus 5x minus 15. And adding those two together, see, it comes back. So we've got our numbers. Okay, so she found her numbers. She was looking for a pair that would add to -2 and multiply to -15, and found that 3 and -5 work. Okay, and then there's one more step. So she sets her, and if you can do parentheses to just show that, like just like we did here. Okay. And then she sets each binomial equal to 0. So x minus 5 equals 0. Okay, and we have to figure out what x is. So how do we undo that 5?
We multiply.
It's just being subtracted now.
Oh, right.
So we'll add, right?
Well, yeah.
Okay, so x equals 5. And then she's going to set the other one equal. X plus 3 equals 0. And how do we undo that?
We minus it.
Mm-hmm. Okay. And so there's our two solutions. Same two solutions, right?
Mm-hmm.
So yeah, just explain. She sets each factor. She sets each factor equal to 0 and solves for x.
Okay.
Or she makes each factor equal to 0 and solves for x. And she gets the same solutions.
Oh. Okay.
Okay. Ready for Tia?
Mm-hmm.
Okay, I like to treat it like a quadratic function that I'm trying to put in vertex form by completing the square. I can then use the square root to undo the squared expression. Okay, so this is how you actually did most of yours on the last lesson. We completed the square.
Mm-hmm. Yeah.
Okay, so I'm going to make it I'm going to make it equal to 0. Put it over there. And then we'll just be doing, so I give myself some space, x squared minus 2x. I'm going to be adding something here, right?
Mm-hmm.
I'm going to be just manufacturing something that will make a perfect square trinomial. But I have to put my -15 here. This is vertex form. Y equals, remember when we did that? X minus h squared plus k, right?
Yeah.
So we're going to make this happen. So I look at this number. I cut it in half. What's half of -2?
1. Actually, 1.
Okay, so -1, and then square it. That would, 1 squared is just going to be 1 again, right? But it's going to be positive.
Mm-hmm.
Okay. Now I just added 1. I either have to add 1 over here, or I have to subtract 1 over here. And that's usually what I would do, is subtract 1.
Yeah.
Okay. So now we have 0 equals, so what would this be? What's going to be inside here?
The 2.
The thing that you cut in
positive
half.
2.
Mhm.
Yeah. Or the 1.
So when we cut this in half, we got -1. That's going to be inside. And then we just used this. We just manufactured something that when we multiply it together,
Yeah.
we get this, right? We just created it to work for us. So we have x minus 1 squared plus, oops, what is this on this side?
What is what? The -15?
And then -1. So we end up with,
Oh. -14.
-16.
Oh.
Okay, because these are both negative, so we can combine them. Okay. And now she says that she wants to use a square root function to find the solution. Right? That's what it says there. She wants to use the square root. We have to have just this on this side so that when we use a square root, we come back to x minus 1. Okay? So we need to get the -16 over here. How do we do that? How do we make it cancel?
We do the opposite of the.
Yeah. So in this case, we're going to, it's being subtracted, so we're going to
Add it.
Add it to both sides. Okay. And then we get 16 equals this perfect square that we created. Okay. And now we're going to do the square root of both sides. Okay. What's the square root of 16? Like what times itself equals 16? Or you can ask your calculator.
4.
Yeah. Now it could be +4 or it could be -4, right? Because -4 times -4 is also 16. So we end up with 2 possibilities. And then on this side, it's going to be x minus 1 because we're just going to take off the root and the power undoes each other, right? If I take the square root of a squared thing, I come back to the base. Now we net all this. So we've got 4 equals x minus 1. So we're going to get this, make that cancel, so we know what x equals. How do we make that go away?
Are we doing the square root again? Or?
No, we just want to move it to the other side, so we have x alone.
We're adding it?
So we've got x equals 5. We know what the answer is going to be because we've done it so many times now, right? What's the other answer going to be?
16.
No, what's the other solution? We have 5 and we have
-1.
-3, right? Okay, so now let's set this other possibility equal. It will come up to -3. -4 equals, see how I'm just solving this now. We took the square root of both sides, and to solve a quadratic, we have to have our x's, right? X equals.
She's so done with me, too.
So on this side, we're going to add, right?
Yeah.
There we go. So again, we have those same two solutions. Okay.
Mhm.
So I'm going to leave this up. And now you just kind of have to figure out how to explain that or show the work step by step. So you're going to say something like, is it Tia?
Yeah.
Tia completes the square to get the equation in vertex form. And then just show this stuff here. Right? We're going to make this 0. Okay, so do something like that without all my scribbles. But keep your parentheses.
Okay.
And then at this point, I don't know if you can just say she takes the square root of both sides. And then she's going to get these two equations. When she takes the square root of both sides, she's going to get 4 equals x minus 1. And negative 4 equals x minus 1. She solves for x and gets that same solution that we've been getting.
Yeah. Okay, done.
All right, last one, right?
Yep.
What does T-honey do? I also like to treat it like a quadratic function. I use the quadratic formula. Okay. So I don't know that we've done this much, but let's. So the quadratic formula is just something that mathematicians came up with to find the x's in a situation like this. So here's the quadratic formula. It's negative b plus or minus the square root of b squared. It's kind of complicated. Let me get that cleaner. B squared minus 4ac over 2a. Okay, so that's the quadratic formula. Okay, now let me show you how we do it. It's not as bad as it seems. We're just going to plug in numbers. So here's our thing. We said to make sure that it's in this standard form. And then the first number is a. What is the first number here? I don't see a coefficient. What would it be? What would be in front of that x? It's understood to be just a 1.
A 1,
right?
Yeah.
Yeah, okay. The second number is going to be the middle number. That's going to be b. Negative 2 is going to be b every time we see b. And then this third number is going to be c. Okay, so a, b, c. So it's not as bad as it seems. Okay, so I'm going to stick in negative 2 everywhere where I see b. I'm going to go negative 2. Have to pay attention to my signs. Plus or minus the square root of negative 2 squared Okay, take away 4. Now what is A?
X.
What? Then just the numbers. We're not worrying about the variable.
4? No.
It's 1. 4 is part of our equation, so it's going to be there
So-
every time.
Yeah.
But A is 1,
One.
and C is, let's see,
15.
negative 15.
Negative 15.
Okay. And now we've got 2 on the bottom times A. What was A?
1.
1. So it's just 2. Okay, we don't have to worry about that. Okay, now we're just going to do this. What is negative 2? What's the opposite of negative 2?
Positive 2?
If it's just going to be positive 2, right?
Yeah.
Okay, so positive 2 plus or minus the square root of what's negative 2 times itself?
Positive 2?
Negative 2 times negative 2.
Four.
4. Okay. All right. And now what is negative 4 times 1?
4.
Still negative 4, right?
Yeah.
Negative 4 times negative 15. Now we're going to get a positive number there.
60.
Uh-huh. Okay. And if I add 4 and 60 together,
46.
64. Yeah.
Oh, yeah. 64.
So under here, altogether, it's 64. Okay. So, and then this is still over 2. It's getting better. All right. What is the square root of 64?
8.
Yeah. So it's 2 plus or minus 8 divided by 2. Okay, we're going to have, again, two answers, right?
Mm-hmm.
So I'm going to do 2 plus 8 divided by 2.
Nine.
2 plus 8 is 10 divided by 2 is...
Oh. Sorry, I thought you meant like the whole thing was that.
Oh.
So 4 divided by...
This is going to be... Our square rooting is done. We've just got 2 plus 8. And then divide that answer by 2.
5.
Yeah. And now we're going to do a second possibility. Okay, we did the plus. Plus or minus means you're going to end up with 2, right? Now we're going to do 2 minus 8 and divide that by 2.
Okay. -3.
Mm-hmm. Okay. So she just decided to use the quadratic formula.
Of course, 10 divided by 2
and
is
you
5.
do your best to get that in there.
I learned that freaking 3rd grade.
And just show step by step, like try to plug in your numbers. Let me erase this and put back the numbers that we had. I'll clean it up a little bit and you can try to copy it.
Okay.
So we had and then in the end, when we did all of that, we got this. plus or minus 64. All right.
Mhm.
Oh, yeah. And maybe we should put one more step in there. 2 plus or minus 8 over 2. Oh, I already had that there. Yeah. And then make 2 equations. So kind of complicated to type in. I don't know if you even have a square root symbol.
Yeah, I don't, but I'll figure something out.
Okay.
Okay, and then are we gonna be done after this?
Yeah, I think so. I'll just, yeah, you got to go, right?
Yeah.
Let's see, add, subtract, remove to apply. I'm just going to pull up an IXL. Complex numbers. There we go. Okay. So this is what I'm looking at. Oops. There we go. This would be what your quiz is going to be. Okay.
Mm-hmm.
So look at this and do as much or as little of it as you want to practice. If you do this complex numbers thing, then for sure submit it as your IXL, right?
Yeah.
But you just need to be able to do all things complex numbers, right? Remember that I is the square root of -1, right?
Mm-hmm.
Okay, so these two things need to be in your notes. I equals I. You're going to find this. I squared comes back to -1. Okay, I to the third is -1 times I, so it's negative I. I to the fourth is 1. Okay, and then this pattern repeats itself, repeats itself, and repeats itself.
Mm-hmm.
Okay, so if you have 2I to the fourth, it's going to be the same as 2 times 1. Okay, if you have 2I to the sixth, we're going to take away 4. And that would be the same. 2I to the sixth is going to equal the same thing as 2I squared. Because this is just a repeating pattern. It's a cycle.
Yeah.
I to the fifth is going to be the same as I. So we would have 2 times -1.
Mm-hmm.
See? Okay, so about a third of your quiz is going to be understanding these powers of I. Okay, so you want to have this written down.
Mm-hmm.
If you have it written down, you can figure out any I. If I have I to the 45th power, I can figure this out. I just need to know where I am in the cycle. So I would do 45 divided by 4,
Mm-hmm.
which gives me 11, remainder 1. So if I have a remainder 1, that means I'm here in the cycle. So it's going to be the same as I. So I to the 45th power is just going to equal I. Okay, it's just a cycle over and over and over again. Okay,
Mhm.
so make sure you have that in your notes. And then as far as this other part, I don't think you'll have any problem. You're just going to treat everything as though I were X. Okay, you're going to multiply this by distributing like you would if I were an X or any other variable. Okay,
Mhm.
if you have to add I's together, we can do that, right? Just like if it were X's. Right? If we multiply, then we're going to multiply those, and then we're going to get phi squared, right? If you every time you get an I squared, it's -1, so we're going to end up here with -10. Okay, so I'll just do what you feel like you want to do and need to do to practice for that. And if you get your IXL to 80, great, you can submit it. If you don't practice that much, then you can do an easier IXL.
Okay. Okay.
Okay. Good luck on that.
Thanks.
I will see you Tuesday.
Yeah. Okay. Thank you.
Bye.
Bye.
You're welcome.
Dude. I was like, thank you. Thank you. Thank you. Bye. I'm sorry, I didn't know you came. Stop, you guys aren't supposed to join these. I was literally in math class. What do you want? Oh my god.